Welcome to Zaption Tour 5.6, Parallel and Perpendicular Lines. There are 5 boxes. The essential understanding that we want to take away from this lesson is that you can determine the relationship between two lines by comparing their slopes and their y-intercepts. So that's what we're going for in this particular unit. So let's get into it. Let's do box number 1 right here. Okay. Box number 1 says this: what does it mean if two lines are parallel, and versus what does it mean if two lines are perpendicular? Well, here is what it means for two lines to be parallel. I have a picture down below of two parallel lines. One is blue, one is red. These two lines are parallel because they are two lines that lie in a coordinate plane that never ever intersect. So two lines that lie in the coordinate plane, but they never intersect, okay? Meaning they never cross each other and they never touch. Okay, let's compare that to what it means if two lines are perpendicular. Okay, I have two lines, and these two lines here are perpendicular. There's a blue line and there's a red line. And you'll notice that these two lines do intersect in the coordinate plane. But the difference is they intersect in a special way. They intersect at right angles, meaning 90 degrees. So this is going to be very important for this lesson. This is what it means to be perpendicular, two lines that intersect in the plane at a special way. And this is what it means to be parallel, two lines that lie in the plane that never ever intersect. Box number 2. Let's talk about slopes of parallel lines. So take a look at this picture over here. I have a red line and I have a blue line, right? These two lines are parallel. But notice that they are non-vertical lines. They're not straight up and down. They're kind of slanted. So what does it mean to have the slopes of parallel lines for non-vertical lines? So what it means is this: they will have the same slope, all right? They will have the exact same slope, but they will have different y-intercepts. So this is what it means, the definition for parallel lines, slope of parallel lines, and non-vertical. So here's what they're saying. So the slope of this line, right, is up 1 and over 2, or excuse me, up 2 and over 1. And the slope of this line is up 2 and over 1. So therefore, they are parallel because they have the same slope. But notice that they definitely have different y-intercepts. The y-intercept of that red line is up at 3, and the y-intercept of the blue line is down at 1. So non-vertical lines, their slopes will be parallel, but their y-intercepts will be different. Now take a look at parallel lines, but vertical. Okay, now we can't really talk about their slope in this case because their slope is undefined. It's straight up and down. So there is no slope for this one. So other than the line that is basically the y-axis, then we have to take a look at how do we define vertical lines and their slope. Well, you'll notice that they're just going to have different x-intercepts, right? The intercept of the blue line is -3. The intercept of the red line is 5. That's how we determine parallel lines that are vertical in the coordinate plane. Box number 2 is an example. It says, write an equation of a parallel line that passes through the point 12, 5 and is parallel to the line y equals 2/3 x minus 1. So to help us solve this problem, I've created a visual of what we're doing. The red point over here is the point 12, 5. I put it in the coordinate plane over 12 up 5. The blue line that you see is the equation of the line that was given right here, which is 2/3 x minus 1. So I'll write this down here, y equals 2/3 x minus 1. That's the equation of the blue line. What we want is the equation that would be parallel to this line but goes through that point. So we want something that kind of looks like this, okay? How do we get it, all right? Well, because we want a line that is parallel, we know that it has to have the exact same slope as the line that we see on the page. So we're going to start with that. So if I begin by y equals mx plus b in slope-intercept form, I'm going to say y is equal to, the slope that I want is the one that's given to me because it has to be parallel. So I'm going to say 2/3 x and then plus b. So remember, we said back up in the first box that if they're parallel lines and they're non-vertical, they're going to have the same slope but a different y-intercept. So I need to solve for b. The way that I solve for b is I use the point given. Here's x and here's y, and I substitute in. So I say 5 is equal to 2 thirds x plus b. So, I substituted in an x for that. The x value would be 12. So I'll get this. 5 is equal to, well, 12 divided by 3 is 4, times 2 is 8, plus b. So coming over here, I would subtract 8 from both sides, and I would get that the b value is equal to negative 3. So when it's all said and done, the equation that I'm looking for would be this. Y is equal to 2 thirds x minus 3. So if I were to graph that one, it looks pretty darn close, right? My y-intercept, I guessed it to be here, and it's actually at negative 3. And then if I go up 2 and I go over 3, I would draw, that line would pass directly through that point, and I would have a line that is parallel to the line given and passing through the point 12, 5. Box 3 is a U-try. It says write the equation of a line that passes through the point negative 3, negative 1, and is parallel to the line y equals 2x plus 3. Look back at box 2 if you need help. Hopefully you got the right answer. If not, here's the solution. We're going to begin by saying y equals mx plus b. I've graphed the information given to help give us a visual as to what it is that we're doing. So I've graphed the line y equals 2x plus 3, and I've graphed the point negative 3, negative 1. So what we're looking for is the equation of a line that goes through that point and is parallel. So we begin by saying y equals mx plus b. Since it is parallel, we know that it has to have the exact same slope. So we're going to say y is equal to 2x plus b. Now I'm going to use the point that's been given to match up my equation here. So the x value is negative 3, the y value is negative 1. So negative 1 is equal to 2 times negative 3 plus b. So negative 1 is equal to negative 6 plus b. I'm going to add 6 to both sides, and I'm going to see that b is now worth 5. So therefore, the equation that I'm looking for would be this. Y is equal to 2x plus 5. And that's the correct answer. Box 4 is an example. It says write the equation of a line that passes through the point 2, 4 and is perpendicular to the line y equals 1/3 x minus 1. Well, to help visualize the situation, I have graphed for you the line. Here's the line, y is equal to 1/3 x minus 1. And I've graphed for you the point that's given to us, which is at the point 2, 4. So since it's perpendicular, we wish to seek the line that intersects the blue line at a right angle. So we want the equation of a line that intersects at a right angle. Well, one important piece of information that we need to understand is that perpendicular lines have opposite reciprocal slopes. So what do I mean by that? Well, here's what I mean. If the line that we have been given has a slope of 1/3, then the slope that is perpendicular, and this is the symbol for perpendicular, has to be the opposite reciprocal. The word opposite means opposite sign, so it's going to be, since 1/3 is positive, the opposite of that would be negative, and the reciprocal means to invert my fraction. So instead of 1/3, I'm going to have 3/1, or just the number 3. So the slope that would be perpendicular would have to be negative 3. That's the opposite reciprocal of 1/3. I'm going to start with that. So therefore, here's what I have. Y is equal to mx plus b. Y is going to equal the slope that I want that would be perpendicular would be negative 3x plus b. Now, use the point that's been given, x and y, the point that I want it to pass through. So 4 is equal to negative 3 times the value of 2 plus b. Therefore, 4 is equal to negative 6 plus b. Add 6 to both sides, and you would see that b is equal to 10, which makes pretty good sense if I graph that line up there. So therefore, the equation that we're looking for here is y is equal to negative 3x plus 10. Box number 5 is going to be an example. I'm going to ask you a series of questions, and I want you to ask the questions, answer the questions based off of the graph that you see here.